So we are left with 2 pages. This video will talk about how is the serial interface implemented. So is that what are the allowable voltages for the logic to be 0 or 1. Alright, if you remember previously we were talking about the zeros and then 1 and then you send a 1 bit and then 0 and then 1 you send another bit, things like that. Alright, so therefore this is alright, there's no problem if you have a components that is within your own system. Alright, that means if you have a computer, this is your microcontroller, these are your devices. Alright, and then this is the SDA line that we're talking about. You can connect to this device or what. Alright, things like that. Alright, this is okay if you are talking about within its own system. However, how can we communicate if we are going to talk about if you were to connect with a PC. So this particular system is gonna connect with another PC. Okay, then computer, then you're gonna have a little bit problem. Alright, so what are the problems? Because the voltage that is specified by this particular system may be certain voltage for 1 or 0. Okay, however, for all PC serial ports, alright, the voltage may be different already. You may require higher voltages in order to be a logic 1. Alright, things like that. Alright, so you may require higher voltages, which in other sense, what is considered a logic 1 may be considered logic 0 for the PC. Right, because because in order to reach a certain because the PC says that if 5 volts then logic is equals to 1. Alright, if it's less than 5 volt, if your voltage is less than 5 volt, then logic is equals to 0. For over here, this thing over here is that, for example, if it's 3 volt, alright, then your logic is equals to 1. Alright, if your volt is less than 3 volts, alright, then the logic is equals to 0. Alright, so in this case, if the logic is equals to 1, then you just apply. So if you want your logic to be 1, then you supply 3 volt. But however, if you were to transmit your data towards the PC now, the PC reads that if only 5 volts, then the logic is 1. So otherwise it is equals to 0. So at first for this system, alright, the high logic is actually 3 volt, which is logic is equals to 1. So if you were to go into this PC zone, alright, this logic equals to 1 that works for this particular system, alright, may not be working for this PC because it requires 5 volt in order to be logic equals to 1. Yeah, I think you get what I mean. I know my explanation sucks, but yeah. So for example, let me repeat again. This thing over here is your whatever device that you want. Okay, then not whatever device, maybe your another PC. Okay, so this PC has its own microcontroller and its own devices. The things that we were talking about in the previous stuff for your I2C. Okay, but in this PC, in order to have a logic, in order to be 1, alright, you're gonna supply 3 volt. Otherwise, if it's lesser than 3 volt, then it's equals to 0. So you send 1 byte of data. So this byte of data contains a 1010 type of thing. Alright, so you send it to this PC. However, this PC over here, in order to be 1, it must be 5 volt. Alright, so all this logic over here, this this is equals to 1, right? This particular system. Alright, this thing over here is 1, this thing over here is 0, this thing over here are all zeros, this is 1, right? If you see what I mean. Another 0, and then over here 1, and then 0, 1, 0, I think I mean. So therefore this is the meaning of that. So over here 5 volt is equals to logic 1. Alright, otherwise anything less than 5 volt will be equals to 0. Okay, so for a signal that sends from this PC to this one, alright, this PC will actually read everything as 0, 0, 0, 0, 0, because you require 5 volt to be high. But however, the highest is actually 3 volt only. I think you get what I mean already, right? So therefore this is the problem now. Alright, therefore what they do is actually to introduce the USB, the universal serial bus. Alright, so that you can actually convert the powers to whatever powers that you are looking for. Okay, between different computers. Okay, so therefore this method is faster and also provides limited power through the buses. Alright, so limited power meaning for for example, you would ensure that both of the PC, alright, their logic, alright, is in order to be high, this must be 4 volt, alright. Maybe in order to be high, this must be 4 volt. Okay, sorry, in order to be high, this must be 3 volt, for example, for the USB. I don't know what for the USB how many volt, but if this is the case, the USB actually connect this PC to another PC, or such that in order to this protocol will tell these two PCs, you should use different colors. So over here, this is 3 volt, right, for in order to be 1. So this protocol for the USB, you're gonna tell this two PC that if you supply 3 volt, then I'll have a logic of 1. If you are more than 3 volt, right, if you have more than 3 volt, then it's also equals to 1. Alright, that's the meaning of that. So therefore, if over here it supplies 5 volt, then if it's a let me see. Yeah, you know what I mean. Lazy to say already. But anyway, the USB, its purpose is to ensure that both of the PCs, alright, in order for them to have the same, for example, if 1, then you need 3 volt. If 0, then you get less than 3 volt. Alright, so it's gonna synchronize their logic 1, 0 in terms of the voltage. Alright, so the USB acts as a synchronizer to synchronize different PCs. Alright, using a limited voltage. So one limited voltage, I don't know what is a limited voltage, but some voltage that is compatible for any PCs. Alright, so that all PCs can read data in the same manner. Alright, in other words, the USB over here is going to take data from this PC and tell this PC will tell, and this USB will know that for 3 volt it is equals to 1. So if I were to connect to this PC, for 5 volt it is equals to 1. So it will tally the informations within this PC, trying to synchronize with this one. So over here is equals to 3 volt. Alright, so in any of the case, if it's 5 volt or 3 volt, alright, this PC will still output a logic of 1. Okay, so in this case, if that's the case, then it's less than 3 volt, then it's equals to 0. So the condition has been changed. It happened that the USB is being connected in this manner. Alright, so this will specify to this PC, this old PC, that this particular PC over here uses a different voltage for its own logic. Alright, so these are the little stuff that you want to understand. Hope that this is really clear. I don't know whether am I saying it clear enough, but anyway, so this comes the last page lah. Yay. Alright, so different PCs, alright, then you will use a USB port. Alright, so the serial interface is being implemented. One way is to use the USB port. Alright, if you are talking about one device to another device, you are talking things within its own devices, then you are going to talk about I2C. Alright, I2C it helps to transmit data. Alright, while USB also helps to transmit data, but in terms of the voltage synchronized between different computers. Okay, and then let's go to this one. So can a bus use asynchronous data? Alright, and that in order to have a bus that sends asynchronous data, alright, the local interconnect network LINBUS will do this thing. So a LINBUS can help you to use asynchronous data. Okay, that's just the meaning of that. Your LIN. So whenever they ask you asynchronous data, which bus can I use? I will use a LINBUS. If it's synchronized one, if it's synchronized, then I will use the I2C bar. Alright, if it's asynchronized, I will use the LIN bar. But the LIN bar wise is a little bit slow. Alright, as mentioned over here, these are slow and need to communicate with each other, but rarely with other systems. So it's within its own system, but in terms of asynchronizing. So you're taking slow things because it's sending things in terms of a very slow pace, I think. I don't know why, but anyway, so just take note that the hardware is pretty simple and resistant to electrical interference. Alright, and it's intended to complement CAN bus, where I don't know what is CAN bus. In the text, alright, the CAN bus is used for automotive. Okay, so over here the automotive, the CAN bus allows you to actually connect your security, your door, your your cluster of your speedometer, your transmission, your engine, whatever. You use your CAN bus to control them. Okay, so so therefore in normal normal domestic appliances, normally we use the LINBUS. For automotive, we use the CAN bus. Okay, maybe I should write it down. Yeah, somewhere. I think I just write it in the comments lah. Alright, so these are the things that you need to know lah. So for CAN bus that uses asynchronous data, straight away you dig the toe is LINBUS. Alright, and then it's for domestic purposes or domestic appliances. If it's CAN bus, then you will talk about automotive stuff already. Alright, and likewise the CAN bus, alright, is also an asynchronous serial bus also. Alright, but the asynchronous CAN bus is used for automotive. Alright, nonetheless, you also have a I2C, which is a synchronized system. Alright, that helps you to communicate within our own system only. Alright, the CAN bus and the LINBUS helps you to connect with to other systems. Okay, so by pictorial definition, you have a microcontroller and you have multiple devices within this particular system all over here. This is a microcontroller, these are all your devices. You have some hardware. Alright, you will use the I2C, alright, bus to actually run your system, alright, using synchronized way of method. Okay, you can also take in asynchronous information by having the UART. Alright, the UART is a universal asynchronous receiver. So you receive asynchronous system for you also. So within itself, this particular device can program things with using a synchronized system or a clock. We call it SCL and SDA, right? The data. So you need 2 wire and lastly the ground for your I2C. Okay, so this is particularly one device, but if you want to connect with particularly one hardware, I should say. Alright, so if for example you have another hardware, alright, and then you need to connect with other hardwares. Alright, so if you want to connect with other hardwares, you can use the LINBUS mostly for the mostly for the domestic appliances, like talking about slow responses and things like that. Alright, so the LINBUS helps you for domestic, alright, to connect with other hardwares, while the CAN bus, alright, helps you to connect with other devices for the automotive system. Okay, so these are the 3 things that I think can be fairly useful for you to understand. Alright, so I think this is it for all the communications within any systems, and I kind of think I did not a good job. But anyway, so actually we didn't go much to the RS232, but if you want to know more about RS232, you can go to video 6. Alright, at the end of the video you'll see a video. Alright, video within a video. Alright, so you can watch that one. But I2C, most likely you'll know the thing already. Alright, and you can implement your, and they know that I2C is a synchronized bus. It's a bus because it connects different devices within its own system. Asynchronized, this RS232 is not synchronized and is also not a bus. Alright, so take note of that. Okay, and that you can implement your communication system. Whilst we are talking about communications between microcontrollers, or communication with microcontrollers and between hardwares and things like that. Alright, so definitely if you talk about purely in software, if you want to code your microcontroller to take in synchronized data or asynchronous data, you can use the general purpose of the input-output pin to actually code it for, so each pin can take in whatever devices and can take in asynchronous or synchronized system or data. Alright, and you use the software to code. When you talk about using a software to code, this means that you're going to talk about the big banging, because you're going to talk about using a software to code the bit and things like that. I don't know, but anyway, this is one of the method. The other way is that you can use specialized interfaces. Alright, it's a common protocols for your things that we have. I think we have talked about it in the I2C. We talk about it over here at part 8. You can also watch part 9. Alright, you can watch these 2 videos. I think it's fairly a good bit, alright, to talk about that. Alright, so we talk about the protocols to be used for asynchronous or synchronized system. Alright, and good idea is to use interface chips when high voltages are required, as in RS232 and LINBUS. Alright, so when you're talking about different interfaces between different hardwares, alright, you can use the LINBUS or the CANBUS. Alright, nonetheless you can also use RS232 to communicate between hardwares. Alright, so each hardware inside has its own I2C that communicates by itself within its own system. Alright, nonetheless you can also have I2C that communicates within different hardwares, I think, but I don't know. But most likely I2C is being implemented within a hardware itself. Alright, while talking about communication between different hardwares, then you use the LINBUS. Okay, which the LINBUS itself is a asynchronous system. Okay, so I hope that this gives you a full conclusion and an understanding of everything about communications of different stuffs. So see you soon.